Welcome dear students. Today we will discuss about basic concepts in food processing and preservation. The objectives of today's deliberation are to study the basic principles of food preservation, to learn about the various scales of operation, to learn about the various steps of processing, to study the common methods of food preservation, and lastly to discuss what is the scenario of food processing in India. People process foods every day when preparing meals to feed their families. However, the term food processing is broader than preparing and cooking foods. It involves applying scientific and technological principles to preserve foods by slowing down or stopping the natural processes of decay. Food processing changes basic raw materials into tasty, attractive products that provide variety of the diets of consumers. Food preparation and processing can be defined as any change that is made to a food to alter its eating quality or shelf life. The aims of food processing can be understood under following headings. First, extending the shelf life during which food remains good both in terms of microbial and biochemical characters. Second, providing or supplementing nutrients required for health. Third, providing variety and convenience in diet. Fourth, value addition to food. The scope of food processing includes processes after the harvest of raw materials until they are processed, packaged and sent to the point of sale could be considered part of food processing. Typical processing operations may include raw material handling, ingredient formulation, heating and cooling, cooking, freezing, shaping and packaging. These could broadly be categorized into primary processing and secondary processing. Now, first let's understand what primary processing is. Primary processing is the processing of food that is carried out soon after harvesting or slaughter. Primary processing ensures that foods can easily be transported and are ready to be sold, eaten or processed into other products. For example, mango is graded, cleaned and packed, which can be eaten fresh. Second is secondary processing. Secondary processing turns the primary processed food or ingredient into other food products. It ensures that foods can be used for a number of purposes, do not spoil quickly, are healthy and wholesome to eat, and are available throughout the year, for example, seasonal fruits. For example, production of mango pulp or slice for canning. Now, dear students, let's discuss the basic principles of food preservation. The basic principles of food preservation involves inhibiting the growth and activity of microorganisms, inhibiting the activity of endogenous enzymes, inhibiting the chemical reactions which may deteriorate the quality of food, inhibiting the invasion and spoilage by insects and rodents. Several methods are available for preservation of food based on the above principles. These are preventing the accessibility of food to microorganisms by asepsis and packaging, physical removal of microorganisms from food by filtration or centrifugation, hindering the growth and activity of microorganisms by use of preservatives, use of low temperatures, atmospheric control in packaging and storing of foods, and decreasing water activity in foods by drying or evaporation. Killing the microorganism by use of high temperature and ionizing radiation, inactivation of endogenous enzymes by moderate heating, inhibition of chemical reaction through the use of chemical additives, fermentation of foods to yield more stable or less perishable food product. Food preservation as it is practiced in the industry always involves combination of methods for achieving maximum effectiveness. However, as much as 50 to 60% of fresh food can be lost without processing between harvest and consumption. This may be because of wrong storage and transportation, which allows microorganisms or pests to spoil the stored food. Improved storage can greatly reduce these losses. Production of most processed foods uses more than one of the categories. For example, jam making involves heating, removing water, increasing the level of acidity and sugar, and packaging. In addition to preserving foods, secondary processing alters their eating quality. For example, wheat. where primary processing is cleaning, drying and milling to produce flour. However, flour is inedible. Secondary processing is used to produce a wide range of rotis and bakery products, snack foods, beer, etc. Foods should have an attractive appearance or color for the consumers to buy. Hence, processing industry should ensure that the products meet the requirements of the consumers. Now, dear students, let's understand the scales of operation. When operating as a business, food processing can take place at any scale from a single person to a multinational company. First is home scale processing. Individual families or small groups of people working together usually process foods that are intended for household consumption. Many of the world's multinational food companies started from a single person or family working from home. In developing countries, home-scale processors are to generate extra income. When this becomes successful, they expand production and develop first into a micro or small-scale business and later into large-scale operations. Characteristically, home-scale processors cannot afford specialized food processing equipment and rely on domestic utensils such as cooking pans and stoves for their production. They may work part-time as the need for money arises and use part of the house or an outer building for processing. However, in many situations, the lack of dedicated production facilities means that there is a risk of contamination and product quality may be variable. This may lead to low-valued processed foods. Second is micro-scale processing. When families generate a good income from their home-scale operations, some may choose to invest in specialty equipment such as bakery oven or a press for dewatering or a pulp-making machine. This allows home-scale businesses to expand and become micro or small-scale enterprise. Home processors may sell their products to neighbors or in village marketplaces. The micro-scale processing requires additional skills and confidence to compete with other processors and marketing. Similarly, although the quality of their products may be suitable for rural consumers, it may not be sufficient to compete with products from larger companies. To successfully expand to micro-scale production, village processors need technical skills to make consistently high-quality products and financial. They may require assistance or short training programs to establish improved production methods, quality assurance and selling techniques. Small-scale processing, the expansion to a small-scale processing operation requires additional investment to produce larger amounts of product in a dedicated production room. It requires specialized equipments. At this level of production, they need to develop attractive packaging, quality assurance techniques and the financial and managerial skills that are needed to run a successful small business. Many governments promote the development of small-scale food processing enterprises because they have the potential to create significant levels of employment, increase food security for growing urban populations as well as rural families, produce products that can substitute for imported foods or have export potential, help reduce balance of payments problems and improve the overall prosperity of the country. Third is medium and large-scale processing. These industries are professionally run with a certain level of automation. The products are of uniform quality with strict quality control and quality assurance. These products are sold over large geographical areas with attractive packing and are advertised well. These companies procure their raw materials from assured suppliers with strict quality controls. The products are normally well researched and tested over a large base of consumers before it is brought to the market. Now, dear students, let us understand the steps of processing. First, raw material handling. Raw material handling is the very first step in the food processing. Raw material handling includes transportation from farm to primary processing units, where it is sorted, cleaned or sanitized before it is dispatched to markets or to processing plants. Second, cleaning and sanitation. Cleaning and sanitation of raw food material could be considered the first step in controlling any contamination of foreign materials or microorganisms during food processing. Cleaning removes foreign materials, that is, soil, dirt, animal contaminants. These operations retard the growth of harmful microbes, which may cause disease and produce toxins. Sanitization is the use of any chemical or other effective method to reduce the initial bacterial load on the surface of raw materials or food processing equipment. Third, engineering properties of food, biological and packaging material. Knowledge of various engineering, physical, thermal and thermodynamic properties of food, biological and packaging material is critical for successful product development, quality control and optimization of food processing operations. Fourth, microbiological considerations. Most raw food materials naturally contains microorganisms which bring both desirable and undesirable effects to processed food. For example, many fermented food like ripened cheeses, pickles, sauerkraut and fermented sausages have considerably extended shelf life, developed aroma and flavor characteristics over those of the raw materials arising from microorganisms such as Lactobacillus, Lactococcus and Staphylococcus bacteria. On the other hand, raw food material also contains pathogens and spoilage organisms, for example, Escherichia coli, Listeria monocytogenes and Clostridium botulinum spores. Different pathogenic and spoilage microorganisms have varied degrees of resistance to thermal treatment. Fifth, role of acidity and water activity in food safety and quality. Intrinsic food properties like water activity, acidity, redox potential helps to decide food processing operations needed to ensure food safety and quality. High acidity levels helps in minimizing the microbial load which requires milder treatments to preserve, for example, orange juice or tomato products. By lowering the water activity by the addition of salt or sugar, microbial growth can be controlled. For example, jams and pickles. Sixth, reaction kinetics. During processing, the constituents of food undergo a variety of chemical, biological, physical and sensory changes. Food scientists and engineers need to understand the rate of these changes caused by applying a given processing agent and the resulting modifications. These controlled process operations help to produce a product with the desired quality. Enzyme hydrolysis, browning and color degradation needs to be controlled during processing. An insight into microbial and chemical kinetic equations to predict and control various changes happening in the processed food needs to be studied. Now, dear students, let's discuss the common methods of food preservation. Following are some of the common techniques and methods that are used to convert raw food into the processed food. First, drying. Microorganisms need moisture to grow, so when the concentration of water in the food is brought down below a certain level, they are unable to grow. Moisture can be removed by the application of heat, as in sun drying, which is most popular and oldest method of preservation. In present days, mechanical drying has replaced sun drying. This is a more rapid process as artificial heat under controlled conditions of temperature, humidity and airflow is provided. Fruits and vegetables like green peas, cauliflower, mango, mahua, etc. are blanched and dried to such an extent that the microorganisms are destroyed. Second, chemical preservation. Microbial spoilage of food products is also controlled by using chemical preservatives which do not include salt, sugar, acetic acid, oils, alcohols, etc. The inhibitory action of preservation is due to their interfering with the mechanism of cell division, permeability of cell membrane and activity of enzymes. The two important chemical preservatives permitted in many countries are sulfur dioxide and benzoic acid. These two are also permitted in India according to FSSAI. Third, smoking. Many foods such as meat, fish and others are processed, preserved and flavored by the use of smoke, mostly in big smoke houses. The food processing technique is quite simple, and the combination of smoke with the aroma of hydrocarbons generated from the smoke processing enhances the taste of smoked food. Fourth, salting. Salt at a concentration of 15 to 25% is sufficient to preserve most products. It inhibits enzymatic browning and discoloration and also acts as an antioxidant. Salt in the form of brine is used for canning and pickling of vegetables. It exerts its preservative action by causing high osmotic pressure resulting in the plasmolysis of microbial cells, dehydrating food as well as microorganisms by drawing out and tying up the moisture by ion hydration, ionizing to yield the chloride ion which is harmful to microorganisms, reducing the solubility of oxygen in water, sensitizing the cell against carbon dioxide and interfering with the action to proteolytic enzymes. Third, preservation by sugar. Syrup containing 66% or more of sugar do not ferment. Sugar absorbs most of the available water with the result that there is very little water for the growth of microorganisms. Hence, their multiplication is inhibited and even those already present die out gradually. Thus, sugar acts as a preservative by osmosis. Fruit syrup, jam, jelly, marmalade, preserve, candy, crystallized food and glazed fruit are few examples of preservation by sugar. Fourth, freezing. Microbial growth and enzyme reactions are retarded in food stored at low temperatures. Low temperatures can be produced by cellar storage, refrigeration or chilling, and by freezing. Fifth, preservation by carbonation. Fruit juice beverages are generally bottled with carbon dioxide content varying from 1 to 8 grams per liter. Though this concentration is much lower than that required for complete inhibition of microbial activity, it is sufficient for supplementing the effect of acidity on pathogenic bacteria. Another advantage of carbonation is the removal of air, thus creating an anaerobic condition which reduces the oxidation of ascorbic acid and prevents browning. Sixth, pickling. In this method of food processing, the food is cooked in chemicals and materials which destroy microorganisms. Usually, these include brine, vinegar, ethanol, vegetable oil and many other types of oils. Pickling is very commonly seen in vegetables such as cabbage and peppers. Seventh, preservation by acids. Acid conditions inhibit the growth of many microorganisms, hence organic acids are added or allowed to preserve foods. Acetic acid, citric acid and lactic acid are commonly used for preservation. About 2% acetic acid prevents spoilage of many products, for example, onions bottled in vinegar with a little salt. Vinegar is also added to pickles, chutneys, sauces and ketchups. Citric acid is added to many fruit squashes, jams and jellies to increase the acidity and prevent mold growth. Eighth, preservation by oil and spices. A layer of oil on the surface of any food produces anaerobic conditions which prevents the growth of molds and yeasts. Thus, pickles in which enough oil is added to form a layer at the top can be preserved for long periods. Spices like turmeric, pepper and asafoetida have little bacteriostatic effect and their ability to prevent growth of other microorganisms is questionable. Their primary function is to impart characteristic flavor to the food. Ninth, preservation by antibiotics. Certain metabolic products of microorganisms have germicidal effect and are termed as antibiotics. Very few antibiotics are used to preserve fruits, vegetables and their products. They effectively reduce the thermal process requirements necessary to control the spoilage of several food products. Nicene is an antibiotic produced by Streptococcus lactis, an organism commonly found in milk, curd, cheese and other fermented milk products. It is commonly used in canning of mushrooms, tomatoes and milk products. Nicene suppresses the growth of spoilage organism, mainly the gas-producing, spore-forming bacteria and toxin-producing Clostridium botulinum. Subtilin, an antibiotic obtained from certain strain of Bacillus subtilis. It is most effective against gram-positive bacteria and spore-forming organisms. Canned peas and tomatoes contain 10 and 20 parts per million of subtilin respectively were found to be free of microorganisms. Pimaracin, an antifungal antibiotic, can be used for treating fruits and fruit juices. 10th, preservation by irradiation. When gamma rays or electron beams pass through foods, there are collisions between the ionizic radiation and food particles at atomic and molecular levels. This results in the production of ion pairs and free radicals. The reaction of these products among themselves and with other molecular results in physical and chemical phenomena inactivates microorganisms in the food. Thus, irradiation of food can be considered to be a method of cold sterilization, that is, food is free of microorganisms without high temperature treatment. For example, control of infestation in stored cereals, prevention of sprouting of potatoes, onions, etc. 11th, vacuum packs. Here, the food is packed in airtight bags and bottles in a vacuum area. An airtight environment does not provide oxygen needed by germs, especially bacteria, to survive. This method is very commonly used for preserving processed nuts. So, dear students, this was all about today's deliberation. Hope you have learned some new exciting things. Thank you for your attention. Have a great day ahead. Goodbye.